Hello guys, welcome to Road to Genius. I know it's been a while since I posted a video. I've been very busy with stuff. Okay, so today I'm going to start up a new episode for chemistry, which we're going to be trying to do a mechanistic approach to learning the elements. And I mean mastering or memorizing certain aspects of the elements, making it to make it easier to remember when you're trying to remember where an element is in the periodic table is, or its properties, or its mass, or things like that that have already been calculated down. Now, if you're looking for how they got those things and the in-depth view into that, I'm sure there are many videos out there, and I'm going to focus on that later, but that's not going to be part of the mechanistic approach. That's going to be more for in-depth analysis of what they did to get the mass or whatever has been you know the case recently. So right now we're going to be looking at a mechanistic approach to the elements on how, starting from hydrogen, of course, because hydrogen is the first element on the periodic table. It's also the lightest on the rest. So we're going to be starting with that. This is just episode 1. This one contains 9. The 1, 2, 3, 4, 5, 6, 7, 8, and 9. 9 properties they're going to be looking into today. 15. We're going to be mastering it 15 times. You know how it's done, the mechanistic approach. Now, uh, I'm going to paste the timestamp, for where the thing begins. If you want to skip the intro and the rest, right? So that's not going to be a problem. Okay, so we're going to be looking at hydrogen. We're going to be looking at helium next, and then I'm going to be looking at this episode 1 of all the elements, all the known elements that are as much as I can, if as far as I can go. So we're gonna be looking at that, starting with hydrogen and going down to wherever. Okay, so we're beginning with hydrogen. Okay, the first thing we're going to understand, we're just dealing with 9. The next episode is going to be the same all elements with new aspects to them, is going to be a different amount, not longer this amount because I'm mastering in this video, but something else. uh okay, that all being said, and sorry for rambling, now we can begin. Okay, so first things first, we're going to look at this. This is the phase. This is gas and it's colorless. I think you all knew that, so I'm not going to dwell too much on it. So we're going to look at the first thing, the atomic number. The atomic number is 1. Okay, so we're going to cover that as we usually do. Okay, so now, what is the atomic number? Well, the atomic number is 1. And again, the atomic number is 1. And again, the atomic number is 1. What's the atomic number of hydrogen? The atomic number of hydrogen happens to be 1. The atomic number of hydrogen happens to be 1, and the atomic number of hydrogen happens to be 1. It's 1. Yeah, we're talking about the atomic number. What is the atomic number? Interesting. Hydrogen's atomic number is 1. Uh, is the number of protons in the atom. Anyway, so it's 1. So the atomic number is 1. The atomic number happens to be 1. Hydrogen's atomic number, can you guess it? Well, it's 1. And it's 1. And it's 1. Moving on. What period is hydrogen? Oh, okay, the period is 1. You see, it's very fun. Okay, period of hydrogen is 1. The period of hydrogen is 1. The period of hydrogen is 1. And the period of hydrogen is 1. The period of hydrogen is 1. The period of hydrogen is 1. Where is the period of hydrogen? Well, hydrogen happens to be in period 1. Hydrogen is in period 1. Hydrogen is in period 1. Hydrogen is in period 2. No. Period 1. If you talk about periods, that's the thing that goes across. So not sure I should be written like anyway. Hydrogen is in period 1. Okay. Hydrogen is in period 1. Hydrogen is in period 1, and hydrogen is in period 1. What group is hydrogen in? Now, look at this. Isn't this so lovely? You never seen this before. That's actually a number called number 1. Actually, when you see this asterisk above these things, this means that these are very important in terms of practical use, right? You can only use them practically. So to use them practically, you need these asterisks, right? So these other ones, they're useful, but uh, for calculations or for understanding, the affinity for electrons, you don't really use them, to be honest. Anyway, back to what we're doing. So the group, hydrogen is in group, like its period 1. Hydrogen is in group with the same number of its period and its atomic number, which is 1. Hydrogen is in group what? 1. Hydrogen is in group 1. Hydrogen is in group 1. Hydrogen is in group 1. Hydrogen has the group of 1. Hydrogen is an alkali metal group. Fun fact. Though it's not a metal, it's a gas, but it's an alkali metal group. Actually, it's an alkali metal, and it's not alkali earth metal. Those are two different things. Alkali earth metal has to do with things like magnesium, and there's no gases in alkali earth metal. But there's a gas in alkali metal, and the only gas is hydrogen, and the alkali metal group is what? Group 1. So hydrogen is in group 1. 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 Okay, now we get more interested since everything since now has been about 1. You think that's boring? Think of me when I was writing it. Yeah. So if you want to memorize this thing, I say just watch it over. You don't have to just watch it and pay attention to each time I write down the thing and just memorize them like that, right? Okay. So what block is hydrogen in? Well, the first block we know. We're going to discuss blocks later in all shells, blocks, and electrons, spins, and the rest of that. The first block we know is S block. There's SPDF and yeah. So S block. It's an S block. Okay, that's good. Hydrogen is an S block. Hydrogen is an S block. Hydrogen is in the first block, which is S block. Hydrogen is an 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 S block. And hydrogen is an S block and it's an S block. So they're both an S block. Actually, it's only S block. So that's that. What is the configuration of hydrogen? Remember SPDF, so it's 1s1. What is this 1? Is that the valency? We'll find out later. Is that the electron? We'll find out later. Or you can easily go on YouTube this. It's actually pretty easy stuff. Anyway, so there's a good video. I think I might put the link down of that explains. I put a link in the description. Okay, that explains why hydrogen is 1s1 and how to find the shells, how to find the groups and the rest of that. And even it goes as far as to explain. I don't think it explains the 3D group 3D elements. We have to do with the shells and stuff. Anyway, I digress. So the configuration. That's not what we're not explaining stuff here. We're just memorizing. The configuration of hydrogen is 1, of course, S1. Smallest one, right? It's the configuration of hydrogen is 1s1. Hydrogen's configuration is 1s1. Watch this till you get brainwashed. Hydrogen's configuration is 1s1. Its configuration is 1s1. Its configuration is 1s1. Its configuration is 1, S1, and its configuration is 1, S1. Its configuration is 1, S1. Its configuration is 1, S1. Again, remember, if you already know this one by heart, you can always go to the timestamp and get to the next one. Its configuration is 1, S1. Its configuration is 1, S1. Hydrogen's configuration is 1, S1, right? Hydrogen's configuration is what? 1, S1. Hydrogen's configuration is what? 1, S1. That's hydrogen's configuration. It's 1, S block, then 1. Now, yay! Here we go. Very sexy, right? We go back to 1. Now, these are not the same things. It just so happens that there's one valency. What's the valency? A valency electron is the electron in its outermost shell. And we discuss that much more later. Anyway, so the valency of hydrogen is 1. Of course, it has one electron in its outermost shell. Sorry for that. There was some kind of a skip. Okay, so I did not record this, which was sad, and I kind of skipped it by mistake. All right, and I show you it wasn't my fault. So let me take it back to this size. Right, it was the camera. The camera just went up for me. I didn't even know. I was like thinking I was doing stuff. So I already went through these ones. Anyway, I'm just going to breeze through them quickly. So a valency again is 1. The valency is 1. The valency of hydrogen is 1. The valency of hydrogen is 1. And the valency of hydrogen is 1. The valency of hydrogen is 1. I can do that because it's going to make it quite crazy. The valency of hydrogen is 1. The valency of hydrogen is 1. The valency of hydrogen is 1. You can actually just listen to this and just close your eyes and just listen to me talk about the valency of hydrogen and just memorize it through that. The valency of hydrogen is 1. It has one hydrogen, one electron in its outermost shell. The valency of hydrogen is 1. 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 Okay, we go back here. The electronegativity following the Pauling scale. The electronegativity of hydrogen is 2.20. 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 The electronegativity of hydrogen. The electronegativity of hydrogen is 2.20. 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 I would advise you can just brainwash your kids with this. If you have a child, you can just brainwash him with this. That would be great stuff. Steady camera. I'm a very poor cameraman. Anyway, so let's go to the radius. Radius is in PM. If you know what PM is, that is very small. That means its diameter will be 55 plus 55. That should be 100. Damn, apart mass. 0, that's 0, carry 1. That is going to be 110, if I'm not mistaken. Yeah, another skip again because I just discovered that my file size was small, so I had to remove some unwanted videos and start again. So that was what caused it the first time. Now this is the second time, right? And I'll just show you how bad I was in math. I'm not really bad in math. I'm just slow when I'm doing something else. And now we're going to also do another episode for that, mathematics and stuff. Anyway, back to what we were doing. Sorry for the skip. So we have 55 PM. That is way smaller than nanometers. It's really, really small. And I said it's going to be in diameter. It's going to be 110. Sorry, 110 that in diameter. in diameter. It's a radius. Anyway, 110 pm in diameter. Okay, so back to what we're doing. Let me not waste your time further. And that is 55 pm. So radius in pm is going to be, radius of hydrogen in pm is 55 pm. Radius of hydrogen is 55 pm. Prime Minister. Radius of hydrogen is 55 pm. The radius of hydrogen, that means the diameter is going to be 110 pm. Anyway, the radius of hydrogen is what? 55 pm. That is really small. God. Anyway, the radius of hydrogen is 55 pm. 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 You don't have to, you don't really need to know this. You just need to, maybe if you're doing membrane filtrations and you're doing reverse osmosis, maybe that's when you need to know this kind of stuff. The radius of hydrogen is 55 pm. 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 Okay. Now, to me, for the arguably the most important one, da 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 da, the mass. This is actually the stuff you need for even calculating anything like molar masses and stuff like that. You have to know the molar mass of hydrogen. That is the mole. There's the grams per mole of hydrogen in 1 mole, which is a very, very big number. We are going to talk about that much later. Okay, so we're going to do a video on that, on just general principles like moles and numbers like that, right? Anyway, so we are now going to talk about hydrogen, right? The molar mass of hydrogen in grams per moles. Well, is this one, you really need to memorize this. 1.008. Yep. So it's the molar mass of hydrogen is 1.008. 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 Come on, you can do it. This is the most important stuff. So just keep on. The molar mass of hydrogen is 1.008. The molar mass of hydrogen is 1.008. The molar mass of hydrogen in grams per mole is 1.008. The molar mass of hydrogen in grams per mole is 1.008. The molar mass of hydrogen in gram per mole is 1.008. Oh boy. The molar mass of hydrogen in gram per mole is 1.008. The molar mass of hydrogen in gram per mole is 1.008. Oh, and that is that. So, if we remember, the atomic number is 1. The period is 1. The group is 1. The block is S block. The configuration is 1s1. The radius is 55 pm. That means the diameter is going to be 110 pm. The Pauling scale electronegativity is 2.20. The molar mass is 1.008 grams per mole. And that is 1 for atomic number, 1 for period, 1 for group, S for the block, 1s1 for the configuration, 1 valency, I forgot this one, 1 electron is valency shell, 2.20 in the electron configuration, with a 5 pm in radius, and 1.008 in molar mass. 1.008 in molar mass. Very important. Okay, thank you.